So basically, what is differentiation? Differentiation is basically rate of change. So small change in y and small change in x. We also write delta y, delta x, or we write then after dy dx. So change in dependent variable and change in independent variable. That is differentiation, okay?
Okay.
See, let's say we have a curve, and in this curve, let's say we take 2 points. So one point is, let's say, x1, and other point is something, x2. And here, corresponding y1 and y2. So if we join these 2 points by a line, so this gives us average rate of change, average change. That is what? y2 minus y1 upon x2 minus x1. See, you have to understand one thing here, that if we have a straight line, then rate of change remains same throughout. Like you take any 2 points and you see rise upon run, that will remain always same, Let's say this is 2, this is 1. Let's say this is 4 and this is 2, So the gradient basically is a rate of change. You take instantaneous or average. That is same. It doesn't change on a straight line. But if we have a curve, then you see that rate of change, if you take any 2 points, that keep changing basically, I mean, like say if I'm taking 2 points here, see, is different. If I'm taking here, it's different. Here it is different. See, rise is increasing and run is decreasing, because this is increasing function. So basically, yeah. So basically, average change we can find by finding a difference between the two values of y and by dividing the difference of two values of x. But if we are finding the instantaneous rate of change, then what? We have to take 2 points which are very, very close. For example, I'm just drawing a curve here again. Look at this 1 point. So I'm just taking this point as x1. And I'm taking a point which is very close to it. So x2. So one point is x1 and other point is x2. Right? And the difference between the 2 points is very small. I'm just making this much difference just to show, because if I take even smaller, then I won't be able to show this. And corresponding y value is here now is fx1, and the other corresponding y value is fx2, isn't it? Right?
Yeah.
So instead of writing x2, what I'm writing it, x plus h. And instead of writing x1, I'm writing x. And similarly, I'm changing fx1 and fx2 as fx, and the other one is what? Fx plus h, right? H is what? Is a small difference in x. Basically, x is independent variable and y is dependent variable. So value of x we can control, but we can't control the value of y because that depends on x. So difference we can create only in x. Y difference will come automatically, you know. So if we are finding the derivative, I mean the change. So what, the formula is what? Formula is y2 minus y1 upon x2 minus x1. So this is, let's say, y1, this is, let's say, y2. X is, let's say, x1, and x plus h is, let's say, x2. So what I'm writing here now, y2, which is fx plus h minus y1, which is fx. The whole thing is divided by x plus h minus x. And I'm writing one more thing here, a limit. That h I have taken very small. So I'm just writing h tends to 0. So because I have taken a very small change in x, so whatever small change has created in y, so that ratio is called the derivative. I can say dy dx, or I can say f prime x. Is that point clear to you?
Yeah.
So the derivative, so we can write like simply instantaneous instantaneous rate of change, which is fx plus h minus fx divided by, and this you can see x is cancelled by this x. It's subtracted. So only h is left. And I can write limit h tends to 0. So that's a basically first principle formula. First principle formula for derivative. Okay, derivative we can represent by dy dx. We can present also by f prime x. These are the way, depends on the variable. Like, I mean, like if variable is t, then we can write dy dt. I mean, when time is changing, then y is changing. Right? If we can write ds dt, depends. Let's say if two variables are v and u, so we can write v is independent variable, u is dependent variable. Let's say we can write du dv. You know, so that is the change in u when v is changing. Right? So what is this giving us actually? At this point, you see, it is giving us a very small change. That is what a slope of the curve at that point. Look at this. So this, if we draw a tangent at that point, and the tangent will have a gradient. So this, at this point, we can get the gradient of the curve. And we change the point. Let's say I'm taking another point. Let's say I'm taking this point. So what? If I'm drawing another tangent at this point. So this is giving, at this point, we will get the gradient of the curve, which is same as the gradient of the tangent at that point. Right? So derivative function, we get a derivative function, f dash x or f prime x. This is giving us gradient of the curve. So it's a gradient function. And if we want to find the gradient at a particular point, so let's say we want to find gradient at x is equal to, let's say, some point A. It may be 2, 3, 4, or negative number or positive number, anything. So we can write fa and we can input that value in place of x, and we find the gradient m. of the curve at that point A. And this is a function, which is what we get by differentiating it.